Right. Good morning. Today I'm going to discuss with you about problem solving algorithms. So in today's session, I'm going to discuss with you about flowcharts and pseudocodes as two different solving algorithms. So first, directly move on to flowcharts. Let's see what is the outline that I'm going to cover with you today for flowcharts. So we'll discuss basically what is a flowchart, what is a program flowchart, and importance of program flowcharts, the standard symbols that we use to draw flowcharts, and the control structures that we need to know when constructing or when drawing our flowcharts. And with that knowledge, I'm going to discuss some exercises with you at the end. So let's directly move on to what is a flowchart in general. What do you mean by a flowchart? A flowchart is a visual representation of the sequence of steps and decisions need to perform a process or need to achieve a task. It's a visual representation of a sequence or set of steps and decisions need to perform a process. Let's consider a simple task, simple process of making a cup of tea. So for you to make a cup of tea, you need certain inputs and you have an expected output. So what do you need to make a cup of tea? What are your inputs? You need tea leaves, you need sugar, and you need some water. What is your desired output? A cup of tea. Now to get this cup of tea out of these inputs, in between you have set of activities and decisions to be made. Representing these steps in graphically, we can make a flow chart. Now let's see how to draw a flow chart to this process, making a cup of tea. So you start your process, and once you start your process, to make the cup of tea, you need to first boil the water. So the first step is boil water. Once you boil the water, you add the boiled water to a cup, and then you add the tea leaves to that cup. And what you should do next, you keep it aside for 2 minutes. And after that, you strain the tea leaves. Now, these are the steps that we are following in order to make our cup of tea. So you strain the tea leaves, and once you strained the tea leaves, you add some sugar, and once you added the sugar, you need to taste it and see whether the sugar level is okay. So you taste the tea. After tasting the tea, you need to make a decision. You need to check whether the sugar level is okay. So is sugar okay? If no, if the amount of sugar that you added is not enough for your taste, you repeat this step. You add sugar again. So whenever you added the sugar, you need to taste your tea, and whenever you taste your tea, you need to check or make the decision whether the sugar is now enough. If yes, either you can consume it or you can serve your cup of tea. So with that, you end your process of making a cup of tea. Now, can you see it? describes, visually represents the set of steps and decisions making a cup of tea. So simply, a flow chart is a visual representation of steps and decision to achieve a particular task. So with that knowledge, now we can see what is a program flowchart. A program flowchart is a graphical representation of a computer program. It's like you can have flowcharts for your business decisions. You can have flowcharts for your real life activities like making a cup of tea. Those are problem solving algorithms. So similarly, you can have a flowchart for your computer program. So a program flowchart is a graphical representation of a computer program. So why, before start coding of your computer program, why do you need to graphically represent it? So this program flowchart is something similar to a blueprint of a house. Whenever you bought a land, before you start constructing your house, you draw a blueprint. So similarly, whenever a customer asks you to do a computer program, so whenever a customer asks, rather than just sitting in front of a computer and typing the program, you draw a flow chart, you build the logic within, and you make sure what you are going to do is what the customer is requested. Now, if you consider this same blueprint example, whenever you buy a land, soon after, if you start constructing your house, having your plan in your mind, without confirming whether you are doing the correct thing, once it is done, say there is no front door to enter into your house, or you need to go to your toilet directly through your kitchen. What do you need to do? You need to rebuild. You need to reconstruct, which will cost a lot, rather than the time that you spend on making the blueprint and the model and confirm whether you are doing the correct thing, whether you are building the correct house. So it's far more better to spend some time and confirm that what you're going to construct is what you really, really want, is important time-wise, cost-wise, and effort-wise. So program flowchart is something similar to a blueprint of a house. Let's see what are the importance of these program flowcharts. So it acts as a communication medium between the developer and the customer. When the customer asks you to do something, you can draw the flowchart and you can discuss that with your customer. It's a graphical representation. There is no any high tech involved in it. So anyone who is not highly technical can understand what it is. So it is a very good communication medium with you and your customer, because there is no any specific technical things involved. It's a graphical representation. So whenever a customer asks you to do a computer application, you can draw the flow chart and you can discuss with your customer, is this what you really wanted? Then he can confirm, yes, no, this is not what I expected. This is what I expected. This is what I need. So you can correct it. But if you, whenever a customer asks you something, you sit in front of the computer, you write the program, you create your application, and you give it to the customer. Customer said, no, this is not what I wanted. It will affect on the customer's trust, and it will affect, you have to do the work again. If you are hiring 2 or more people to do that, you need to pay them again. If you're doing it by yourself, it's your effort and your time which you could have spent on something else that you have to do it again. So it's very important. It acts as a communication medium between the developer and the customer. And it helps you to clarify your understanding of the program to be developed. You can make sure, okay, this is what I have to do. Rather than doing it again and again, once you confirmed, okay, this is what I have to do, it's easy for you to construct your code. To identify the places where the improvements are needed. Now, in certain places, once you draw, when it is graphically represented, you can identify, okay, rather than having a sequence structure here, I can reduce the number of steps if I use a repetition structure. So you can go for program code optimization. So you can identify the places because it's graphically represented and you can clearly understand it, so that you can identify the places where you can make improvements for the program. So those are the main or key importance of drawing a program flowchart before you directly moving into constructing your program code. So you clearly understand the logic, and then it's very easy for you to convert that to a program. Right. So just a small recap. Which statement is incorrect related to a program flowchart? A program flowchart is a graphical representation of a computer program, can be used as a communication medium between the programmer and the developer, unnecessarily increases the development cost and the time, helps to better understand the program to be developed. Now, out of these answers, what do you think? Which statement is incorrect related to a program flowchart? So it's unnecessarily increases the development cost and time. When you go to the IT industry, you might feel it. Oh God, why we are wasting time of drawing these and building these logics rather than directly start constructing our program, which saves a lot of time. But at the end, what you have done is wrong. Redoing incur a lot of effort and cost. So it's far better to spend a little bit of time and money on making the flowchart and confirming what you are going to do is correct. Right. With that, we can now move on to the standard symbols that we have to use when drawing a flowchart. So there are 6 main symbols that I will be discussing with you today. Terminal symbol, input-output symbol, process symbol, decision symbol, flow lines, and connector symbol. Right, let's discuss these symbols in detail. First, let's move on to terminal symbol. So this is an oval shaped symbol, and if you're using this symbol to indicate the beginning of your program, inside the symbol you write the statement start or begin, or if you're using the symbol to indicate the end of your program, inside the symbol you should write end or stop. So this terminal symbol is an oval shaped symbol which you use to indicate the beginning and the end of your program. So either If you're using this to indicate the beginning of your program, you can either use the statement start or end. And if you're using this oval shaped symbol to indicate the end of your program, inside the symbol you should write the term end or stop. So these terminal symbols are the first and the last symbol of any flowchart. So any flowchart must have these symbols. It indicates the beginning and the end of your program. In any flowchart, you have to have at the beginning this and at the end this. Input, output symbol. So it's a parallelogram. The same parallelogram we'll be using to indicate an input to your program and to indicate an output from your program. So if you are using this symbol to indicate an input, inside the symbol, you write the term input and you need to specify what are the inputs. If you can remember, in our tea making flowchart, you write input tea leaves. So that is an indication of an input. So if you are using this symbol to indicate an input to your program, you should write the term input or enter and you need to give what are the inputs. And if you are using the symbol to indicate an output from your program, you should write the term output and you have to specify what are the outputs from your program. Next is the process symbol. It's a rectangular symbol and it indicates an arithmetic operation or data assignments or simply a process, something that the program does, explains in this process symbol. So it can be an arithmetic operation or a data assignment. So here we say the value for this total is equals to the value inside A plus value inside B. And here we have used a data assignment. For the variable A, we have assigned the value number 10. So this you can use either for arithmetic operations or for data assignments. So next you have the decision symbol. Within your program, if you need to make a decision, diamond shape symbol represents the occurrence of a condition where truth value, true or false, determines the path to be selected. So to write your condition, you use this decision symbol. If you need to make a choice based on a condition, to write your condition, you use this decision symbol or this diamond shape symbol. In all the previous symbols, there is only one flow line going out. But with the decision symbol, there are two flow lines going out. If this given condition is true or if the given condition is false. Now you need to make a choice based on a condition, and to write the condition, you use this decision symbol. For example, you need to check whether the student's mark is greater than 50. If it is greater than 50, you need to decide the student is a pass student. Otherwise, you decide the student is a failed student. Right. With that, now we can move on to flow lines. So flow line with an arrowhead indicates the direction of the information flow within the program. The lines must be followed to understand the sequence of events in the flow chart. So, flow line, a line with an arrowhead. The arrowhead shows the information flow. So these flow lines connect all the symbols in your flow chart. So the symbols are joined together by these flow lines. Next, you have the connector symbol. So when you're drawing your flow chart, if the space, say you're using a page, if the page is not enough for you to draw continuous flow line, the rest of your flow chart, if you're continuing on the same page, you use this on-page connector. And the rest of your flow chart, if you're continuing on another page, you use this off-page connector. So there are two connector symbols, on-page connector and off-page connector. And when do you use these connector symbols? When the space is not enough for you to draw continuous flow lines. If the space is not enough for you to draw continuous flow lines, you can use these connector symbols. The rest of your flow chart, if you're continuing on the same page, you use this on-page connector. The rest of your flow chart, if you're continuing in another page, you use this off-page connector. Right. A small recap for this section. Flow lines are used to show the direction of the information flow within your program, continue the remaining of the flow chart within the same page if the space is not enough, connect all the other symbols of the flow chart together, both A and C. What is your answer? Both A and C. Show the direction of the information flow within your program. Connect all the other symbols of the flow chart together. Right. So with that, now we can move on to control structures. In this section, we are going to discuss about three main control structures. Sequence structure, where you need to follow the steps exactly one after the other. You do the first step and then you go to the next. You do that, go to the next. Steps exactly one after the other. Sequence. Selection structure, when you need to make a choice based on a condition. So you do something. If this happens, do plan A, otherwise do plan B. If the student obtained 50, display pass, otherwise display fail. If you need to make a selection repetition structure within your program, if you need to do the same thing again and again, repeatedly, same thing again and again, that type of a structure we called a repetition structure. So when you draw more advanced flow charts, they can be a combination of all these three control structures. Right. So let's discuss these control structures in detail. Sequence structure. Sequence control structure specifies one program statement after another is to be executed in a given order. So you perform the first step and then you go to the second step and then you go to the next step. So exactly one after the other, if you're to follow the steps within your program to achieve your output, that type of a program we called belongs to sequence structure. Now, when we go to the exercises, before you start drawing your program flow chart, you have to decide what is the control structure that I'm going to use for this program. Selection structure represents a choice between two actions based on a condition. If the condition false, if the condition true, you need to make a choice. So you are making the choice based on the condition. If the given condition is true, you follow one direction. If the given condition is false, you follow another direction. Repetition structure. Within the program, repetition control structure specifies that the process to be repeatedly performed until a given condition is not true or while the given condition is true. Say if you need to input marks of 50 students in a class. So until the student count comes up to 50, you need to keep on entering the student marks repeatedly. Same thing again and again. So there are three control structures. Sequence structure, if you need to follow the steps exactly one after the other. Repetition structure, if you need to make a decision based on a condition. Repetition structure, if you need to do the same thing again and again until a given condition is not true or while a given condition is true. And one other very important thing in computer programming, and this is important in flowcharts as well, you should know the concept of variable. You should have an understanding or idea of what a variable is. Variable is a location in the computer's memory that can store a value to be used by a program. Variable is a location in the computer's memory that can store a value to be used by a computer program. A variable has a unique name and a data type. So we call this location a variable. Why? Because this value varies. So whenever you enters the second value to this location, the first value get replaced. So there you can't find the first value. The value varies. That's why you call this a variable. It's not a constant value. It's a variable value. So variable is a location in the computer's memory that can keep a value or that can store a value, but this value is changeable. Whenever you enter the next value, the previous value will get replaced by the first value. So that's why we call this particular location as a variable. Right. Again, another small recap about what we have done from the control structures. These are the answers. Represents a choice between two actions based on a condition. Sequence control structure, selection control structure, repetition control structure, variable. What do you think? Represents a choice between two actions based on a condition. A selection control structure represents a choice between two actions based on a condition. Right. So far we have now discussed about, in general, what is a flow chart, what is a program flow chart, what are the importance of program flow charts, why you draw program flow charts, and the control structures, and what is a variable, and the standard symbols that we are using to draw flow charts. Now, with that information, we can now move on to the exercises. So I will do one exercise for each control structure so that you will be clearly understand what these control structures are. And there are some other exercises as well. If you need, you can request and I can share the exercises with you. There are a lot of exercises. So this slide shows only 5. There are some independent challenges. Right. So we'll first move on to our first exercise. Draw a flow chart for a program to input 2 numbers and to output the total. Draw a flow chart for a program to input 2 numbers and to output the total. Problem solving algorithm. Now you're going to build the logic behind this problem. Right. Now, whenever you are given this type of a question, you need to first of all think, what is the best control structure? What is the control structure that I should use to achieve this? To input 2 numbers, without getting the 2 numbers, you can't get the total. So you need to follow the steps. Do you need to make a decision here? No. Do you need to do something repeatedly? Lots of times? Only you have to input 2 numbers. And then you need to add the 2 numbers and get the total. And the expected output is the sum of the 2 numbers. So whenever you are given this type of a question, you need to think of what is the control structure that I should use for this, and what are my inputs, and how, based on these inputs, what is the expected output. So there are 2 inputs. You need to input number 1 and number 2. Once you get the 2 numbers, you need to add the 2 numbers and output the total. So any flow chart, as I said earlier, must start with the start symbol. So we are going to use the sequence structure for this, because you need to follow the steps exactly one after the other to achieve your output. Input number 1. So the input symbol is the parallelogram. Once you input the first number, then you need to do what? Input the second number, input number 2. Again, it's an input, so you use the parallelogram. And then you need to perform a task, the computer, within your computer. Once you input the 2 numbers, now your computer should add these 2 numbers and assign the value to the variable total. So you write, then you should get the sum, total equals number 1 plus number 2, and then output the total. Is that all that you have to do? Yes. It says draw a flow chart for a program to input 2 numbers and to output the total. Then what should be the next symbol? You have to have the end symbol, the terminal symbol with the statement end or stop. So you need to follow the steps exactly one after the other. So we call this structure as the sequence structure. You follow the steps one after the other in a sequence. Next exercise. Draw a flow chart to input two numbers and to output the total and the average. Do you need to make a decision here? Do you need to decide something? No. Do you have to do something repeatedly again and again for many times? No, you need to input only two numbers, and once you get the two numbers, you need to add these two numbers and you need to find the average, and you need to display the total and the average. So what are the inputs? So whenever you are given this type of a question, you need to think of what is the control structure that I'm going to use? What is my expected outcome? What the program needs to be expected to be output, and to get this output, what are the inputs that I need to feed into my program? So any flow chart, as I said earlier, should start with the terminal symbol. Inside the symbol, you write the term start or begin. Start. So in the same symbol, if you need, you can write input number 1 and number 2. So you write input number 1, number 2. So which means you're accepting two numbers to your program. So once you get the two numbers, then what you should do? You need to add the two numbers to get the total. How to write this? What is the symbol that you need? This is a process, an action the computer should perform. It should add the two numbers and assign that value to a variable called total. So within the rectangle, you write total equals number 1 plus number 2. And once you calculated the total, then what you should do? You need to find the average. How to find the average? What is the average of two numbers? Average equals to total divided by 2. Now here, if you write average equals total divided by 2, rather than writing it like this, if you write average equals to number 1 plus number 2 divided by 2, is it correct or incorrect? Logically, it's correct. Because you add the two numbers and you divide it by 2. But when you draw the flow chart, you can see the same step you have executed here. If you are doing the same thing again unnecessarily, it takes time. So if you have your total, you don't need to add these two numbers again here. You can simply use this total and divide it by 2. So that's why it says the flow chart is a graphical representation that helps you to find out the places where you can make necessary improvements. So if you have written here, average equals number 1 plus number 2 divide by 2, 100% logically correct. No problem. But you can see you have already added, your computer has already added these two numbers and you got the sum. Why do you need to perform the same thing again unnecessarily? So rather than adding these two numbers and getting the total back again here, you have that value here already calculated, so you can make use of it. And then you need to output the calculated total and the average. So that is what our expected output. And then once you're done with that, what you should do? You need to end the program. Any flowchart must have these two symbols, must have two terminal symbols, one for start and one for end. In between, there are inputs, outputs, and processors and decisions. Right. So with that, we can now move on to our question number 3. A student should receive a pass grade if the mark is more than, we'll make it more than or equals to 50, and fail grade if the mark is less than 50. Draw a flowchart to enter a mark of a student and to display the grade. A student should receive a pass grade if the mark is more than or equals to 50, and fail grade if the mark is less than 50. So whenever you are given this type of a question, as I said earlier, you need to decide to get this expected outputs. What are the inputs that you have to enter? What is the control structure, or what are the control structures that you are going to use? Now for this program, we need to make a choice based on a condition, which means we are going to use the selection structure. And what are your expected outcomes? Should be either pass or fail. So this you decide on what? Decide on the student's mark. So you need to input the mark or feed the mark to your computer system, to your program. Based on the mark that you entered, the computer decide whether the student is a pass student or a fail student. Okay. You begin the program, start. Then you need to input the mark. Whenever you enter the mark, can you directly say, okay, this student is a pass student, this student is a fail student? Can you directly say that? You can't. What you have to do? You need to check. You need to make a decision. What is the symbol? The diamond shape. Inside the symbol, you have to write your condition. What is your condition? I said to make this correct, correct this as mark greater than or equals to. So you write if mark, the value that you have entered, that particular student's mark, if it is greater than or equals to 50. This condition can be true, this condition can be false. If the mark that you have entered is 85, this condition true or false? True. So if the condition true, what you should do? What the computer should do? It should give you an output. What is the output? Output pass. Do you need to do anything else once you give the output? No. You can end the program. If this condition is false, if this condition is false, if the mark is not more than 50, say the mark that you have entered is 35, mark is not more than 50, then output fail. Now, after giving the relevant output, so now this time you input for 35 and you check whether the 35 is greater than 50. No, 35 is not greater than 50. This condition false. If the condition false, you come to this side. It says output fail. And end the program. If this given condition is true, you output pass and end the program. Otherwise, you output fail and end the program. Right. In this, how many lines? 1, 2, 3, 4, 5, 6, 7. Here, 1, 2, 3, 4, 5, 6. But for this, rather than using a variable and using a repetition structure, you might feel, oh, it's easy to write this one. But if this program is to output, say 20, output the word hello 20 times or 100 times, since this program will need only 6 statements and this will need 100 plus 2 statements. Right, so here we are taking a variable as a counter, and when you are using the repetition structure, until the given condition is not true or while the given condition is true, you're repeating. So what happens here, you begin the program. In your computer's memory, you have created a variable and you have given the value 1 to it. While c less than or equals to 5. Now what is the initial value that you have given to c? 1. Is 1 less than 5? Yes. Condition true or false? Condition true. If the condition true, you output hello. You take a piece of paper and write down hello once. Right. And then c equals to c plus 1. You're increasing the value of c by 1. Now initially you have given 1 to c. 1 plus 1. Now what is the value for c? C is now 2. It says go up and check. While c less than or equals to 5. Now what is the value for c? 2. Is 2 less than 5? Condition true. If the condition true, you come here, output hello, right? Output again, hello again, right? And then it says c equals to c plus 1. Now what is the value for c? 2. 2 plus 1, 3. Go up, check whether 3 is less than 5. Yes, condition true, output hello, write hello again. It displays hello again. Increase c by 1. 3 plus 1, 4. Come up. 4 is less than 5. Condition true. Output hello. For the 4th time, you're displaying the word hello. And increase c by 1. Now, what is the value for c? It's 4. 4 plus 1, 5. Come here. While c less than or equals to 5. Now, what is the value for c? C is now 5. 5 is equals to 5. Condition true. Output hello. You give the word hello again and increase c by 1. C equals to c plus 1. So 4 plus 1, c is now, 5 plus 1, c is now 6. You come here while c less than or equals to 5. Now what is the value for c? 6. Is 6 less than 5? No. Condition false. If the condition false, what to do? End the program. I hope you're clear up to this point. So we have discussed about the flowcharts. What is a flowchart? What is a program flowchart? The standard symbols that we use, the control structures, what is a variable, and we have discussed some examples for sequence structure, selection structure, and this last example for repetition structure. So with that, we can now move on to pseudocodes. Pseudocodes is the next problem solving algorithm that we are going to discuss. Sorry, can't go back. You don't need to adhere to specific syntax rules, and it is a set of specific instructions which are very similar to a computer code but not specific to any programming language. And it looks like a computer instruction but cannot be executed on a computer. So pseudocode cannot be executed on a computer. When you, at a glance, you might see it as a computer program, but it is not executable. What is the importance of pseudocodes? Why do you need to write pseudocodes if it is not executable? Because the designer or the developer can fully concentrate on the program logic without being worried about the syntax rules. Now, if you are try to write the program using a specific programming language, as I said earlier, there are specific syntax rules for different programming languages. In Python, you don't need to define the variable by the time you're using, you can define the variable. In certain programming languages, before you use the variable, you have to define that variable. In certain programming languages, you have to put the semicolon at the end of the variable. In certain programming languages, you have to use 2 colons for assignments. So likewise, there are many syntax rules associated with different programming languages. But in pseudocodes, there is no any specific syntax rule for you to follow. Therefore, the designer can totally concentrate on the logic of your program rather than thinking of, oh, do I need to put the semicolon? Do I need to use the colon? Do I need to define whether I need to define the variable? You don't need to think of those. So once the pseudocode is developed, it is very easy for you to convert to a program of any programming language because it's more closer to a programming language, but there are no specific syntax rules. So once you build the logic using pseudocode, you need to apply the syntax rules of that particular programming language to convert this pseudocode to an executable program. So that is the importance of pseudocodes. So with that, let's recap with a small question. What is incorrect about pseudocodes? Pseudocodes cannot be executed, described in detail using English language, no specific syntax rules to be followed, almost looks like a computer instruction. Describe in detail using English language. Doesn't describe in detail using English language, but it describe using short English phrases. You build the logic using short English phrases, not detailed sentences. So with that, let's move on to the exercises. Write a pseudocode for a program to input two numbers and to output the total. The same exercise that we draw the flow chart. So now you're going to write this using short English phrases. So similarly, that any flow chart must have the terminal symbol. Any pseudocode must have the statement start and end. And in between, you're going to write your steps, decisions and selections, and the repetitions. So you start your pseudocode with the start statement. This is not compulsory at the pseudocode or flowchart level. You don't need to define your variables compulsorily. But as a good practice, it's easy for you if you decide on what are the variables that I'm going to use if you decide what are the variables that I'm going to use in my program. So that's why I use this, but it is not compulsory because there are no any standard rules. But okay, it says write a pseudocode for a program to input two numbers and to output the total. Okay, if you are to input two numbers, to get the two numbers, you need two memory locations, and to keep the total, you need another memory location. This is not compulsory, though I did it here. If you can, you can use. If you don't like, you can simply ignore this. So I'll explain this with what happens in your computer's memory. Assume this is your computer's memory. So you begin your program. When you say this, when you define this, this is what happens in your computer's memory. It allocates three locations in your computer's memory with these names and with these values. Number 1, 0, number 2, 0, and total 0. Then it says input number 1 and number 2, which means you need to enter two numbers from the keyboard. The two numbers that you input from the keyboard, where to store in these two variables. Say you input 10 and you input 4. So first you input 10, so 10 goes to this. Second you input 4, 4 goes to this. This is your memory, computer's memory, right? And then it says total equals number 1 plus number 2. It says that add the values in these two locations and the result where to keep here. So in number 1 you have 10, in number 2 you have 4. 10 plus 4, this will be 14. And then it says output total. So what is the value you have? 14. So it will display, assume this is your monitor. So it gives the output 14 and end the program. I hope this is clear to you. So you accept two numbers. The two numbers that you entered are 10 and 4. Sum of 10 and 4 is 14. So you got the correct output. Let's move on to the next exercise. Write a pseudocode to input two numbers and to output the total and the average. Begin the program. Either you can write the statement start or begin. Now, if you are using the variables, defining the variables initially, what are the variables you need? You need one to get the first number, another one for the number 2, and one for total and one for average. Define number 1, number 2, average and total. So when you execute this statement, if you write a computer program, when you execute this program, this is how your computer's memory looks like. So it gets two numbers, allocate two variables to get the numbers, and one for the total and one for the average. Input number 1 and number 2. Say for number 1 you input 5, for number 2 you input 7. And the next statement, it says total equals number 1 plus number 2. 5 plus 7. The resulted value, it says store in the variable total. So which is 12. Average equals to total divide by 2. In the variable total you have 12. 12 divide by 2. What should be the value for this location? It should be 6. So then it says output total and the average. So what it should display? 12 and 6, because in the variable total you have 12 and variable average you have 6. Are you getting the correct output? The two numbers that you input is 5 and 7. Sum is 12. Divide by 2 is 6. And end the program. Right. A student should awarded a pass grade if the mark is 50, if the mark is greater than or equals to 50, and fail grade if the mark is less than 50. Write a pseudocode to enter a mark of a student and to display the grade. You begin the program. You define the variable mark. This is not compulsory, I'm telling again. Right? So which means you're creating in your memory a memory location. The name is mark and you're initially giving the value 0 to it. Input mark, which means enter a value. You input 85. If mark greater than or equals to 50. Now what is the value that you have entered? What is the value in this variable, in this memory location? 85. Is 85 greater than or equals to 50? Yes. If the condition true, display pass. So now the condition is true. It will display pass and end the program. It will not go to the else part. If the condition is false, if this condition is false, it will not go to this true path. It will execute the else part and display fail. Now remember, when you are using this if statement or while statement, you have to have end if statement to indicate where you are going to end this selection. So okay, again the same thing will execute. You begin the program, define the variable mark, and you initially assign 0. Input mark. Say this time you input 40. If mark greater than or equals to 50. Now what is the mark that you have? Which is 40. It's not greater than 50. Condition false. If the condition false, you are not going to this part. You go to else part. In the else part, it says display fail and end the program. So remember, if you use if, you have to have end if statement, and soon after the if statement you write what you should do if the given condition is true. Within the else part you write if the given condition is false. Write the pseudocode to print the word hello 5 times. You begin the program. So I'm taking the memory. Assume that this is your computer's memory. You define, see here defining is compulsory because you are making this as a counter. You're going to count for 5 times. So before you use this, there should be a value for this. So you say c equals to 1 initially. So when you write this, this is what happens. While C less than or equals to 5. Now what is the value for C? 1. Is 1 less than 5? Yes. Condition true or false? True. If the condition true, print hello. Assume this is your monitor. So it displays hello. C equals to C plus 1. What is the value for C? 1. 1 plus 1. C is now 2. So after end while, it goes up here, and not like the if statement. If it is the if statement, you check only once. But if it's end while, it goes up and check the condition, because it's a keyword that we use for the repetition structure. So it goes up and check whether C is still less than or equals to 5. Now what is the value for C? 2. Is 2 less than 5? Is 2 less than 5? Yes. So you come in, print hello. Increase C by 1. C is now 3. And while you go up and C. Print hello again. Then increase C by 1. C is now 3. 3 plus 1. C is going to be 4. And after end while, goes up and check the condition. Whether C is less than 5. Yes. Then display hello. Increase C by 1. 4 plus 1 C is 5. Go up and check while C less than or equals to 5. Now what is the value for C? 5. Is 5 less than 5? No. Is 5 equals to 5? Yes. Still the condition true or false? True. Come in, print hello. So you print hello and increase C by 1. C equals to C plus 1. Now what is the value for C? 5. 5 plus 1, C is 6. And while you go up and check the condition. While C less than or equals to 5. This is your program. It goes and check your computer's memory whether the value for C is less than and equals to 5. Now C is 6. Is 6 less than 5? No. Is 6 equals to 5? No. Condition true or false? Condition false. If the condition false, it executes the statement after end while. What should be the statement after end while? If this condition false, you have now printed 1, 2, 3, 4, 5 times. You should end the program, or you should stop the program. I hope you're clear with the sequence structure, selection structure, and repetition structure, flowcharts and pseudocodes to build the program algorithm and how it works with the computer's memory. Yes, right. So if you need more questions, more exercises, please let me know. I can share more exercises with you. Thank you very much for listening and joining with the session today. Thank you.